In this lesson, we're going to model the formation of an ionic bond. As we know, ionic bonds form between a metal and a nonmetal when the nonmetals gain electrons from the metals, and the bond is the attraction between the cation and the anion. So we want to be able to see that modeled. We want to be able to see the transfer of electrons. We also want to be able to see that attraction between the cation and the anion. So we'll do some examples here. So in this first example, we'll be using Lewis diagrams to model ionic bonding in NaCl. And so what we want to start with is drawing the Lewis dot diagram for each of the atoms. So sodium has 1 valence electron, and we get this information from the periodic table, and chlorine has 7. And as we know from previous lessons, we know how many electrons are going to be gained or lost based on the valence electrons. So with sodium, it has 1 valence electron, and it will have a tendency to lose that 1 valence electron. Whereas chlorine has 7 valence electrons, and so it's going to have a tendency to gain 1 electron. So we've got a perfect scenario here where sodium is looking to transfer an electron or lose an electron, and chlorine is looking to gain an electron. So then we can look at what we have next, and what is left here is sodium has a +1 charge, okay, and chlorine has a -1 charge. And so what we've done here, and this is equal to NaCl, okay, in this 3-step process, we've modeled the ionic bonding in this formula NaCl. Okay, so the sodium has transferred electrons to the chlorine, forming our cation and our anion, and then the attraction or the bond actually is between the cation and the anion. Let's look at another example here with calcium chloride. So calcium has 2 valence electrons, and chlorine, same as before, has 7 valence electrons. So chlorine is still generally going to gain 1, so calcium is going to lose that 1 electron. Now with chlorine, it will only gain 1, but calcium has 2 electrons to lose. And so this is why in the formula we need 2 chlorines. Okay. And so what does this give us? This gives us a cation of Ca2+, and an anion of Cl-, and we have 2 chlorines. Okay? So the difference between this modeling here and just the formula is that in the formula we're focused just on the number of atoms of each type, whereas with the cation and the anion here, we're seeing more of a full picture of what's going on with the bonding. Okay? So in the 3-step process, we see the transfer of electrons, we see the cation and the anion and how many of there are, and then we see the formula. This next one, I'm not given the formula to start with, and there's a couple ways you can do it. You could start from the formula and work backwards, but let's think about this a little bit more from first principles, we say. So just looking at the basics so we can really understand what's going on here in ionic bonding, and then we can have an even better understanding of what we have when we are forming the formula. So when we form the formula and we write down our ions and we do the crossover method, this is the background theory that supports that. Okay. So with this one, I have aluminum nitride. And so what I'm going to do is look at aluminum. It has 3 electrons to transfer or to lose, and nitrogen is able to gain 3 electrons And so then what we are left with is Al 3 plus and N 3 minus, and my formula is Al N. Okay. So in this example, we can kind of see why when we are working with ionic compounds and they have the same charge, it will just simplify. So Ca2 plus and O2 minus, it just simplifies because the metal will lose the same number of electrons that the non-metal will gain. I'm just going to do one more little example here with aluminum oxide. Okay, so with aluminum, again, I have 3 valence electrons with oxygen, and I'm getting this information from the periodic table. Okay, oxygen has 6 valence electrons. So if I go through this systematically, so I've got aluminum is looking to lose 3. So if I give 2 to this one oxygen, this oxygen is not able to gain any more. So if I bring in another oxygen, I can transfer this electron, but then now this oxygen still needs 1 more electrons because it's going to gain 2. So I'm going to bring in another aluminum, okay, and so now the 2 oxygens that are there have the 8 that they need in their valence, and I need 1 more oxygen to transfer these 2 electrons. Okay, so you might think that this process is going to go on forever, but it does stop. As you know, binary ionic compounds are generally made up of small whole number ratios. Okay, so if we look at this now, we have aluminum. Each aluminum has a 3 plus charge, and I have 2 of them. And each oxygen has a 2 minus charge, and I have 3 of them. Okay, so as we've been talking about before, when we're formula writing, our goal when we're formula writing is to ensure that the positive and the negative charge are equal, so there's no net charge. And we can see here clearly that we have a 6 plus and a 6 minus charge. And then when I write the formula without the charges, I have Al2O3. Okay, so hopefully this helps you to review modeling ionic bonding.